Welcome to Digital Logic SECR1013 Section 5. This is our group project and it's titled Elevator Controller System Simulation. Let's get started. First of all, we would like to thank our course professor, Dr. Mohammed, for making this course enjoyable and memorable to learn from. Here is the introduction and the background to our project. Digital logic circuitries are the foundation of modern electronic systems, and they use Boolean algebra, for example, and logic gates to control automated devices. A practical application of this is what we are doing now, an elevator module system. A lift controller is required to respond to user input, track its floor position, and a lot more. We also added quality of life features so that the user experience can be improved as a whole. Let's move on to the problem statement. Many hotels needed a way to secure their premises because the lifts are open access. This developed a need for an authorization system. Otherwise, unauthorized individuals can access the lift without any form of verification. This makes it very risky and the privacy of hotel clients are exposed. Secondly, when they have technical difficulties, users are unable to use the lift. When maintenance workers come, they might need to spend extra time to figure out the issue since there is no error code. Without immediate identification of the issue, this prolongs the waiting and fixing time, causing an inconvenience with everyone.
I'm Ongxun, so now I will talk about the system requirement. For the functional requirement, our lift system is divided into core functions and advanced functions. The core function of the system is to use a synchronous counter to count the lift levels, either counting up or counting down, depending on the selected direction. A converter is also used to compare the desired level selected by the user with the current level of the lift. For the advanced functions, the system includes a door open and close reminder to ensure safe operation. Card and password verifications are also introduced to improve security. In addition, LED indicators are used to alert users to errors such as an incorrect password or when no authentication card is detected. For the hardware requirements, several input switches are used in this system. These include preset and clear switches, up and down switch, a door close switch, a start switch, as well as password and card input. A 7-segment display is used to show the desired level, the current level, and the password input. A 1-bit output display is used to show the level in binary form and to indicate when the door is open. A converter is used to compare the desired level with the current level. A clock generator provided timing signals for the circuit operation. Basic logic gates such as AND, OR, NAND, XNOR, and NOT gates are used to build the control logic. Finally, a counter made out of 3 JK flip-flops is used to control and store the lift level. For the software requirements, the lift circuit was designed and simulated using DIS, which stands for Digital Electronics Education and Design Suite. This allows us to design, simulate, and test the lift system to ensure it works correctly before implementation. This slide shows the block diagram of our lift control system. The clock generator controls the timing of the system, while the start button and door input ensure the lift only operates when it is safe. A JK pivot is used as a synchronous counter to track the current flow. The up or down input control the buffer directions, and the 3-bit converter compares the current flow with the selected flow from the 3-bit switches. The flow number is shown on a hex display. For security, a card reader and password input are verified using a 4-bit decoder. The lift only operated when verification is successful. LED indicators provide status and error alert.
Now I would like to explain the system design. First of all, the first step to design the circuit, we need to have the state diagram. Our lift consists of 8 levels, which is from level 0 until level 7, and then count up and count down. 0 for count up and 1 for count down. Because we are using JK flip-flop, so we need to refer to the JK excitation table in order to get the JK transition table. After the transition table, we are able to produce KMAC because we have flip because we have three flip-flop, so we have to produce 6 KMAC and get the equation. Therefore, we can connect the circuit. After the basic design, we have to introduce the advanced controller design. We have introduced 4 advanced features, which is the password system and card identification in order to prevent the unauthorized person to using our lift. The next one is we use comparator to display the door status. When the current floor is equal to the desired floor, then the comparator output will be 1, and then the door will open. Next, we have the welcome display when the lift is activated, and then we have LED alert to prompt the user about the errors like the wrong password or the card is wrong. After that, we start to design our DIT circuit. We have 2 types of input switch, which is 1 bit binary display and then 7 segment display for user-friendly purpose. This is our output display. Next, we have 4-digit password system and card. This is the LED alert. When all the LED are on, means that all the features are correct and the lift is ready to be used.
Hi, my name is DINIYAH, and now I'm gonna explain our last chapter, which is the conclusion and also the reflection. So it starts from the summary. Our live control system has used the password input, card authentication, door condition, and a start switch to ensure the lift operates only when all the conditions are correct. LED indicators are used to show whether the system status is correct or if an error occurs. We're also using the Jacob flip-flops to control the lift movement and to store the current floor number. The lift is able to move up or down, and the current floor is displayed on a 7-segment display. And the welcome message is displayed when the lift is successfully activated, indicating that the lift is ready for use. The entire circuit was tested using the DIT simulator and functioned as expected. Then, what we already achieved while doing this project, we have doing about 8 points, which is the first is build a working lift control circuit using digital logic gates. And then we successfully implemented a password checking system, and we can add the card, door, and start safety condition. We also use the LED indicators to show error and correct system status. We did implemented Jacob flip-flops to control lift movement and floor counting, and this circuit will be displayed the desired floor using a 7-segment display, and also display the current floor using a 7-segment display also. It will display welcome while the lift is activated, and the last is we have tested and confirmed correct operation using the DIT simulator. Okay, and we also have facing the many challenges while making this project, and we also have tried to overcome by learning how to do that. So actually, it was easy to connect the wrong wire or with a connection when using the DIT simulate to circuit. When using the DIT simulator to stimulate the circuit and make the password work correctly. Yeah, because it's not easy when we want to set up the password. And actually, it's also hard to understand how the lift move up or down when the clock signal changes when using JK flip-flop to stimulate the circuit. And the last, yeah, we also try to figure out how to set up the LED indicators also. So we also add our several future improvement to improve our design to more better in the future by adding more floors to the lift by using more flip-flop and a larger display. And then the password can be more secure by using a longer password. And also we gonna try to use the LCD display, like it will be show the message like a access granted or the wrong password or the door open instead of using only LEDs. And we also plan to adding a buzzer or alarm when a wrong password or wrong card is detected. We also have say our own reflection, and this is by my team members, which is Chiyun, and my own reflection, my own reflection, and also by the Sinyan. And as you can see, this is the appendices, which is the proof or the proof of our project. I mean, this is like a group discussion for discuss about the project, and this is the photo of our first meeting, and this is as this is also the member name and also the task. And then this no. Also, we using the reference by the journal, the Digital Fundamentals 10th edition, and we also refer to our book. No, I mean from the book that provided by University Technology Malaysia, Digitalogy, and from the YouTube also by the NESO Academy. And I think that's all for now. Thank you for listening, and also I want to say very thankful to my team members for making this project successfully. Thank you.